For number 7, we actually have to come up with the model ourselves, the probability model. So we need to read the question and come up with the model ourselves. It says the mechanic identified the problem as dirt in the control unit. So Buck took his minivan in for repairs and there's dirt in the control unit. He said in about 75% of the cases, drawing down and recharging the coolant a couple times cleans up the problem, and that costs only $60. But if that fails, the control unit must be replaced at additional cost of $100 and $40 for labor. So let's come up with all the outcomes here. So outcome number 1 is that recharge the coolant. And that is only $60. So that's outcome number 1. And it happens 75% of the time, right? So $60, 75% of the time. And outcome number 2 would be if that fails. So unit is replaced. And that cost the $60 an additional $100 and $40 for labor. So an additional $100 and an additional $40 for labor. So that would be $200. And we see those are the only 2 outcomes. Either you recharge the coolant and pay $60, or it fails and you have to pay all this. 60 plus 100 is 160 plus 40, $200. So what are the odds of this second one happening? Since they said 75% of the time you just have to recharge the coolant, this one would be 25% because they need to add up to 100%. So my little table here, my list of outcomes and probabilities, my outcome and my probability, my X and my P. So my 2 outcomes are $60 or $200. And $60 has a 0.75, 75% chance of happening, and $200 has a 0.25, 25% chance of happening. And so my expected value would be, I could go to Staple and get it, and I'll do both this time. I'll calculate it manually and then go to Staple it. To get your expected value, you just add up all of the outcome times the probability, because it's called a weighted average. So the $60 has a 75% chance of happening, so 60 times 0.75, plus 200 has a 25% chance of happening, so times 0.25. And we get that, and that is 45 plus 50, which is $95. And so I get $95 when I plug in the formula for expected value, but I also want to show you how to do it in Staple. You can pause if you need to. If you need some more practice in Staple, we'll go ahead and do that. All right. So let's bring up Staple it, and I'll go back. And I'll go to discrete random variables. And we'll call it car repairs. And the $60 had a 0.75, 75% chance of happening. And the $200 had a 25% chance of happening, so 0.25. And I hit begin analysis. And here is my mean and standard deviation. The mean is 95. If they would have asked for standard deviation there, we do have it right there, 60.622. So I wanted to show you how to do that in Staplet as well. So what does this mean in context? In context, it means that on average, a person in Buck's situation, a person with Buck's car problem will pay $95 for their repairs. So it's not $97, $95. Now that does not mean Buck's going to pay $95. He's not. He's either going to pay $60 or $200, right? But on average, if Buck went to this do this 1,000 times, he'd pay on average $95. He paid $95,000 if he had to go get this done 1,000 times, right? So in the long run, that's about how much he'll pay per time he has this problem and has to go do it. But just this one time, it's either going to be 60 or 200, right? Just depending on if he gets lucky or not, and he only needs the coolant. All right, so that is number 7 on our outline.